Hello, welcome to Prep Class Tutors. I am Abel Godwin, so I will be your maths tutor, and we are going to be looking at WAEC mathematics questions for the year 2020. So in this review, we are going to concentrate on questions number 16 to 20. But before we proceed, I would like you to like and comment on our videos, because by so doing, you get to see a lot of exciting content that will bring to you. This promises to be highly educational, so you will do well not to miss this. So please subscribe, like, and comment on our videos. So I would like us to look at question number 16 right away. It says, given that x is directly proportional to y and inversely proportional to z, x is equal to 15 when y is equal to 10 and z is equal to 4. Find the equation connecting x, y, and z. So here we need an equation that will connect these particular variables given to us. And to do this, we need to interpret this statement mathematically. So when we say x is directly proportional to y, in the mathematical term, it's written x directly proportional to y. And when we say x is inversely proportional to z, then it can be written like this. So these two statements, you can picture this as this is a simple sentence, this is another simple sentence, and then they are now joined by a connector, the and connector. So we need to process these two simple sentences to give us a compound sentence. So this, in this regard, we have is a combination of this simple sentence and this simple sentence, which simply implies that x is directly proportional to y, but inversely proportional to z. So usually in mathematics, we need to introduce our constant of proportionality whenever we use the variation symbol. So this made us to arrive at this value of k here. So ky all over z. All you need to do is to write an equality and introduce any alphabet of your choice. So there's no hard and fast rule about it that it must be k. But in most cases, we know that k is for constant in mathematics. So our x is now equal to ky all over z. So now, given that our x is 15, y is 10, z is 4, by the time we substitute into this particular expression, you discover that we have something like this. So x being 15, y being 10, and z being 4. So all we need to do is to solve the value of k here. So by cross multiplying here, we have this expression, or this equation, so to say. And dividing both sides by 10 gives us k to be equivalent to 6. So all we need to do is to come back to the original equation and substitute for the value of k, and this will result to x being equal to 6y all over z. So this is option A. Now proceeding to the next question, question number 17, and it says two buses start from the same station at 9 p.m. Please take note, this movement happens at 9 p.m. I think this is a type of error, and travel in opposite directions along the same straight road. Question says the first bus travels at speed 72 km per hour and the second at 48 km per hour. Now the question is, at what time will they be 240 kilometers apart? So let's look at this pictorially and then we try to make sense out of it. So this happened to be a demonstration of the whole statement that we just read in the previous slide, which is currently here. So we call this vehicle A, moving at 72 km per hour to the left hand side, and this particular vehicle B, moving at 48 km per hour, moving to the right. So you see, the two vehicles are in the opposite direction. So it implies that they are going to be expanding at a faster speed between them. So the distance between them is going to be covered at a faster speed. It's just like two machines working on a piece of farmland at different rates. So you see, the work is going to be completed faster than when either of them happens to be on the field. So here, they started this journey. We can picture where this red mark is as the beginning of their journey, where they both took off. And this happens at 9 p.m. So car A moves to this direction, car B moves to this direction. And exactly 2 hours, exactly 240 kilometers, we need to know how many hours it took them. So to do that, we first of all need to get the resultant velocity. And in this case, which is the sum of their speed to give us the average speed of the whole journey. So 72 plus 48 is going to give us 120 kilometers per hour is the average speed of the two vehicles now. And by the time we look at the formula for distance for speed, which is equal to distance all over time, you discover that time is given as distance over speed. So the distance they covered is 240 kilometers, and this happens using a speed of 120 kilometers per hour. Remember the resultant speed for both vehicles. So this gives us 2 hours as a number of time it took them to achieve this separation. So, and with this you can even reason it first. If the resultant velocity of this vehicle happens to be, the resultant speed happens to be 120 kilometers per hour, it means in 1 hour they will be 120 kilometers apart. And of course, in 2 hours, they will be 240 kilometers apart. And this is what actually we saw here analytically. So it means that they will take 2 hours from their starting point in order to achieve this distance. And so from 9 p.m., by the time we add 2 hours to it, this will land us somewhere around 11 p.m. And so if you look at our options, C is our answer, 11 p.m. Like I said, neglect the use of the anti-meridian because it's a typo error, and concentrate on the post-meridian, because as you can see, all options here are in the post-meridian time. Proceeding to the next question, it says, a solid cuboid has length 7 centimeter, breadth 5 centimeter, and height 4 centimeter. Calculate the total surface area. So now let's look at the diagram representing this. So this is a cuboid. A cuboid is a form of three-dimensional rectangle, because if you're looking at it as a rectangle, like something that has breadth and length, that will be in 2 dimensions, and that is a rectangle. But once the same rectangle has up to 3 dimensions, as you can see here, length, breadth, and height. So what we're looking at there is no longer a rectangle, but a cuboid. So this is a typical representation of the cuboid in question, with size 7 centimeter, with length 7 centimeter, width 5 centimeter, and height 4 centimeter. So we need to get the surface area of this cuboid. The surface area will be the face here, the face on top, the face behind, the face below, the face to the right, and the face to the left. So we need to calculate all the areas individually in order to result to the total surface area. But there is a formula that can save us all that. And this is it. Formula for calculating the total surface area of a cuboid, which says we should multiply twice the surface area of each of the faces. So you see this length times breadth here, we have a replica of it behind. You see this length with 5, height 4, we have the replica here, this side. And so also the top and the bottom are also double gangers. So what we have here is just an interpretation of this figure in the mathematical language. So what we need to do is just to substitute into the expression. Length is given as 7, breadth is given as 5, breadth is given as 5, height is given as 4, height is given as 4, length is given as 7. So as you can see, by the time we operate on what is inside the bracket, we have 35 plus 20 plus 28. Now multiplying this by 2, as you can see, we're going to have 166 centimeter square. So this is option B. Proceeding to the next question, it says in the diagram, PQ is parallel to SR, find the value of X. So let's look at the diagram we're talking about here. So this is the diagram, the question presented. PQ is parallel to SR. So this line is parallel to this line, and we are requested to get the value of X. That's this angle here. So to do that, we need to do extra additional construction here. And by the time we draw another parallel line, so PQ and SR, we're going to have a beam that this angle here is equivalent to this angle, because we have the parallel, this, the newly constructed one, and this, to have this as their transversal. So this is going to be alternate to this. So that's what makes this part or this portion to be 68 degrees. And in the same vein, this same line parallel to PQ, so you can see, so the angle at X is going to also be alternate to the angle at this point marked red. So now, as you can see here, the summation of all this is going to be 360, which is angle at a point. So this is exactly what we did here. X plus 68 plus 246 is going to give us 360. And the rest is history. We just add this and make X the subject of the formula, leaving us with a value that X being 46. So basically, it's just a game of playing with theorems. So lastly, our question says, this, as you can see, is option B. Our question says in question number 20 that find the equation of line parallel to 2y is equals to 3 open bracket x minus 2 close bracket and passes through the point 2 for x and 3 for y. So this is a coordinate geometry question, and we're given a line with an equation, and the line passes through this. So we need to find another line that will actually be parallel to this. And you know, lines are defined by their equations. Just like humans do have names, lines also do have names, and their names happen to be in the specific or particular equations obtained. So let's look at this in the next slide. Here, from this particular equation given to us, by the time you open this bracket, you discover that this is going to give us 3x minus 6, making y the subject of the formula. You discover that 3 all over 2x minus 3 is now a definition of a straight line equation where the slope is 3 all over 2 and the y-intercept is given as minus 3. So if there is any line that is going to be parallel to this, it must have the same slope with it. Why? Because parallel lines have the same slope. So the line passing through 2, 3 has the same slope as this. So we still maintain 3 over 2. And from the equation of a straight line, we want to know the value of the y-intercept of the second parallel line. So here, as you can see, we just need to substitute now m for the slope because they are the same. So we need to substitute the value at which the line passes through the coordinates. And at this point, it simply means that my y is 3 and my x is 2. So by the time I effect this substitution, I'll be left with c being 0, because 2 cancel 2. As you can see, I have 3 is equal to 3 plus c, making c the subject of the formula means 3 minus 3, and that gives us 0. So simply means we need to come back to this equation and put wherever we see c, we can put 0. So this results in 3 over 2x. And so with this, as you can see, the option is reflected as C. So that will be the end of today's edition of the video. And please don't forget, just in case you're just joining us, do well to subscribe to our YouTube channel, like and comment on our videos. Until then, do have a nice day.